Alright, so here we have number 12, which ought to be a great question for y'all, but we'll see. We're supposed to find the mean, standard deviation, quartile ranges, and such for a set of data. And it should be a simple question. It's, put stuff in a calculator. We'll see. All I can say is we'll see. I'm not sounding too optimistic this morning, am I? Maybe I should change that tone. I probably will change my tone when enough of y'all give me a reason. So here's the boring process of putting the data in the TI-84. Oops, typo. Make sure you double check what you type. Obviously I will too. Alright, so once I've got it all in there, I just go to Stat, Calc, One Variable Statistics, and I scroll down to Calculate. And this will give me everything. We've got a mean of about 50.91. What's my median? My median's 45.5, so we're definitely skewed. And we're probably a skewed left. Before I look at the histogram, I'm going to make note of that. Since the mean is above median, probably skew. And I said left, and I don't mean that. It's probably skewed right. Standard deviation is going to be sigma 28.58. What's quartile 1? 31. And quartile 3 is going to be 71. So let's look at the histogram here. We got stat. Sorry, I don't know why I went there. We're going to go to second stat plot. Not second point, second stat plot. And I'm going to turn them on because I'll have my calculators reset. And I'll choose the histogram. And I'll do a zoom 9 because that says stat right there, zoom stat. Yeah, there's your skew right. Now for those of you who don't see the skewness, it's just about drawing a curve over it. I'll draw a curve for you, maybe that'll help you again, I don't know. At least you're not doing algebra, right? Right. So anyways, that is definitely skew right. The best measure of center, and it's because of skew, the best center is the median. So the median is 45.5, and our spread here is going to be 31 to 71. Again, that's 50% of the data. That's normal. Alright? That's what you expect for an average. Something between 31 and 71. It's your interquartile range, if you would. The base of a statue is created by placing 10 rectangular concrete blocks on the ground to create a larger rectangle. So a large rectangle has been created by taking 10 of them. You don't have to draw this. This is just for those of you who can't read. Anyways, there's 10 of them. They're not perfect here. But each cinder block has dimensions given. Oh, missed my dashes on that one. But anyways, the cinder blocks have length x. Oddly enough, the height is 2x. It's weird. And width x minus 2. Evidently, I just made some stuff up and didn't think about what it looked like when it was drawn. But whatever. Write an expression for the volume of the statue's base. So, again, each block is a prism, and its volume is length, width, height. So the volume of each block is going to be, I see an x, I see a 2x, and I see an x minus 2. Now, it takes 10 of them. So 10 volumes would be 10x times 2x times x minus 2. Now, I wouldn't overthink this. I'm not going to require standard form or anything. But 10x times 2x is going to be 20x to the second. And then you got your little x minus 2. If you want, distribute that. There's a reason we stop here. It may not become apparent to kids, to most students, why a lot of times we stop there. We stop because we know, if we think about domain, and that's part of it, that x has to be greater than 2. Otherwise, there is no volume. That's why we stop there. That's why, like on your EOC, they didn't finish all the algebra per se. They stopped there because I can look at that and say, okay, x has to be bigger than 2. Otherwise, there's no volume. If you don't get that, then you don't get it. But if you get it, you understand why a lot of times we stop in certain places. And that is it for the basics quiz. There you go.